Hydrogen. Hydrogen is the simplest and lightest element. It does not occur as a free element on Earth, but exists in combined form. Examples of compounds containing hydrogen are water, hydrocarbons, and sugar. Laboratory preparation of hydrogen. Hydrogen gas is prepared in the laboratory by the reaction between dilute acids and some metals. Dilute sulfuric 6 acid and hydrochloric acid react with some metals to liberate hydrogen gas. Zinc is the most suitable metal for the laboratory preparation of hydrogen gas. Experiment. How hydrogen is prepared in the laboratory. Let us observe this experiment to learn how hydrogen is prepared in the laboratory. In this experiment, zinc granules are put in a conical flask and the apparatus set up as shown. Dilute hydrochloric acid is added using a dropping funnel and several test tubes of the gas produced are collected. When the reaction is slow, a few granules of copper 2 sulfate are added. If the gas is required dry, it is bubbled through concentrated sulfuric 6 acid and collected by upward delivery. When zinc granules are added to dilute hydrochloric acid, there is effervescence and hydrogen gas is evolved. A small amount of copper 2 sulfate crystals may be added to speed up the reaction. Copper 2 sulfate acts as a catalyst. Dry hydrogen gas can be obtained by passing wet hydrogen through anhydrous calcium chloride in a U-tube, or passing it through concentrated sulfuric 6 acid. Nitric 5 acid is not used to prepare hydrogen gas because the hydrogen formed is oxidized to water. However, very dilute liberates hydrogen with magnesium metal. Potassium, sodium, lithium and calcium react explosively with dilute acids, hence must not be used. Magnesium could be used for the laboratory preparation of hydrogen, but it is expensive. Aluminium forms a protective layer of aluminium oxide, which should be washed with concentrated hydrochloric acid before the metal can react with dilute acids. Zinc is preferably used because it reacts moderately with dilute acids. Impure iron gives a mixture of gases including the bad-smelling hydrogen sulfide when it reacts with dilute acids. Hydrogen is a colorless, odorless gas and is insoluble in water, so it is collected over water. Hydrogen is less dense than air and it can also be collected by upward delivery. This method is also called downward displacement of air. Hydrogen has no effect on litmus paper. It is neutral. When mixed with air, hydrogen puts off a burning splint with pop sound. This is the test for hydrogen gas. The intensity of the pop sound diminishes as purity of hydrogen increases. Pure hydrogen burns quietly with a blue flame. Hydrogen does not support combustion, but it burns in air. Experiment. What happens when hydrogen is passed over heated copper 2 oxide? Let us observe this experiment to learn what happens when hydrogen is passed over heated copper 2 oxide. In this experiment, copper 2 oxide is placed in a porcelain boat or on a piece of aluminium foil. This is then placed in a combustion tube as shown. Dry hydrogen is passed through the tube to drive out the air from the apparatus. A sample of the gas from the jet is collected and tested with a burning splint. This continues until a sample of the gas burns quietly without a pop sound. The gas at the jet is lit and the copper-2 oxide is then heated as shown. A steady flow of hydrogen gas is ensured. Heating is done until no other change is observed. The apparatus are allowed to cool as passing of the gas continues over the residue. The apparatus are disconnected and the colorless liquid in the cooler parts of the combustion tube is tested. Air is driven out of the apparatus to ensure the hydrogen being burned at the jet is pure to avoid explosion. On passing a stream of dry hydrogen gas over hot copper-2 oxide, the black copper-2 oxide changes to red-brown. At the same time, a colorless liquid condenses and collects on the cooler parts of the combustion tube. Hydrogen combines with oxygen from the copper-2 oxide to form water, the colorless liquid. The red-brown solid is copper metal. Removal of oxygen from a compound is known as reduction, while the addition of oxygen is known as oxidation. In this reaction, copper-2 oxide is reduced to copper metal while hydrogen is oxidized to water. Hydrogen removes oxygen from copper-2 oxide and is therefore referred to as a reducing agent. Copper-2 oxide loses oxygen to hydrogen, hence it is an oxidizing agent. Hydrogen will also reduce the oxides of lead and iron. Hydrogen does not remove oxygen from oxides of more reactive metals. The supply of hydrogen gas is continued, while the apparatus cools to avoid the reoxidation of the hot metal by oxygen from the air. Excess hydrogen gas is burned because its mixture with oxygen, air, is explosive when ignited. The excess gas is therefore not allowed to escape into the air for safety reasons. Experiment. What is formed when hydrogen burns in air? To learn what happens when hydrogen burns in air, let us observe this experiment. In this experiment, apparatus are set up as shown. A stream of hydrogen gas is passed through anhydrous calcium chloride. The gas is tested for purity by collecting samples over the jet and testing with a burning splint until the gas burns silently. The gas is lit at the jet and the pump is turned on. The products of the burning hydrogen are drawn using the pump. The liquid in the test tube is tested using white anhydrous copper-2 sulfate. When hydrogen burns in the air, a colorless liquid which changes white anhydrous copper-2 sulfate blue is formed. The liquid is water. Hydrogen combines with oxygen from the air to form water. Water is therefore an oxide of hydrogen. Anhydrous calcium chloride is used to dry the gas. The ice-cold water condenses the steam to form liquid water. Uses of hydrogen. Hydrogen is used in the large-scale manufacture of ammonia in a process known as the Haber process. The gas is also used during the hardening of oils to form fats. When hydrogen is passed through liquid oil in the presence of a nickel catalyst, the oil takes up hydrogen and is converted into fat. This process is called hydrogenation. It is used in the manufacture of margarine. Hydrogen is used in balloons because it is lighter than air. A balloon filled with hydrogen floats in air. A light radio instrument can be connected to the balloon to collect information from the atmosphere by meteorologists who study weather conditions. A mixture of hydrogen and oxygen burns to produce a very hot flame, the oxyhydrogen flame, which has a temperature of up to 2000 degrees Celsius. The flame is used in welding and for cutting metals. Hydrogen is used in rockets as fuel. Hydrogen is used in the manufacture of hydrochloric acid. Hydrogen is used as a fuel in fuel cells. Thank you for watching this chemistry lesson. Please subscribe to this channel and other Genius channels relevant to your level of study.